Right guys, today we're going to jump on the Netflix bandwagon once again and look at the film Don't Look Up with Leo DiCaprio and Jennifer Lawrence. So there will be minor spoilers, so if you haven't seen the film, go and watch at least the first 5 minutes and then come back, and then we're going to go through some of the maths. Right, so you remember the first scene where he does the calculations on the whiteboard to calculate the orbit of the comet. Now they don't show much of it, they skip over a lot, and they don't give the initial data, so I couldn't really follow along with much of what they did. I'm going to have a little play around with it in the future, but for today we're going to look at this image here. Now if we draw this here on our board, we've got the angle theta is written there. This looks like, I think, is the Earth because you've got the moon next to it there, and so this would be the sun, and this is the comet he's written now. So at the bottom he has R. He draws his vectors like that. Up here he's got pi, which is a vector, and here he's got, I think that's a rho, okay, because he speaks about rho earlier in the scene. A lot of them look like E's. I draw my rhos with a little tail like that, so they don't look like P's or E's. And then he's come up with, well, he's defined them here. Is equal to, he's doing some sort of iteration, so he's got pi I, but we'll just write pi is x, y, z. And then R is capital X. This isn't important for the calculation, but I'm just copying what's on the screen. Rho is equal to, was it LMN? Okay, and what he's done is he's come up with this formula here. So this would be the distance between the comet and the Earth, and he's gone the distance of pi squared is equal to rho squared minus 2. Now he's not drawn these absolute value signs here, but I think it's just a mistake. He should have drawn them, these lines here. Okay, so we're going to derive this formula. We're going to describe what each of these symbols mean, and then we're going to derive this formula. All right, so first things first, these are vectors. You can tell because he's drawn the arrow above the letter. What is a vector? It's basically an arrow in space. Okay, you can have two-dimensional vectors. So if you've got a plane here, this is the x-axis, and the y-axis you might have some vector AB. So you go along A, and then you go up B, and you call it, and this is the point AB, or the vector AB. All right, and similarly in 3D, let's draw some 3D coordinates. This is Z, X and Y, and you might have some, it's coming out this way, and then this is ABC, whatever, right? So what these vertical lines mean is the length of that vector. Okay, so in 2D, the length of this vector would be L, and we use Pythagoras that we went over last time. So it gives us L squared equals A squared plus B squared, which means L equals the square root of A squared plus B squared. Now can we do that in 3 dimensions? It turns out we can. If the length is L equals the square root of A squared plus B squared plus C squared. As a quick proof of that, if you just consider this triangle first. Now this has got length A because this is the x coordinate and y coordinate B, so this therefore is the square root of A squared plus B squared, and then this distance is C, so therefore L is equal to, well, L squared is equal to this squared, which is under the square root, plus this squared, and then we take the square root and we get our formula there. Okay, so Pythagoras works in 3 dimensions or any higher dimensions as well. But that's just an aside. We don't need that for our calculation we're going to do. We just need to know that this is the length of this side squared, this is the length of this side squared, and this is the length of this side squared. These are the lengths by themselves, and this is theta, this angle here. Okay, so what we're going to do first to try and derive this formula is we're going to, as always, we've got no right angles here. We do love our right angles, so let's make some. Okay, let's drop a perpendicular down there and pop 2 right angles there. Now we can label this length here A, this length here B, A, B, and you guessed it, C. Okay. So let's make up some formulae. First of all, we have Pythagoras once again. A squared plus C squared. A squared plus, what do I say? C squared equals the length of pi squared. Okay. We have another formula on this side. B squared plus C squared equals the length of rho squared. Okay, and we have one further formula here. We've got an angle here. We don't want to get C in our final answer, so let's say cos theta. Let's work that out. Well, that's equal to this length B divided by this length, which is rho. Okay, so now let's play around with these three formulae and see if we can come up with something resembling this. Well, we want pi, the length of pi squared. So let's start with this. Well, we know this is equal to A squared plus C squared. Okay, so now we can write A in terms of R and B. Okay, so this is, sorry, and now we multiply that out, we get this mod of R squared minus 2BR plus plus B squared plus C squared. Now we have here B says B squared plus C squared equals rho squared. So let's write that out again. So we have R squared plus rho squared minus 2BR, and now we're getting there. Look, we can multiply up here to get B equals the length of rho times cos theta. Pop that in there, so then we get R squared plus minus 2R, and then put in our B, rho cos theta. Get a bit mucky down there. Is that on the camera? Yeah. And there we have it, our formula. So not too tricky. This is called the cosine rule. Normally you'll see it in a slightly different form with just A and B's. So it looks a little bit simpler in this form with just A, B's and C's. We're a little bit more familiar with those, right? Rather than rho and pi and vectors and whatever. But it's the same thing. We use that quite a lot as well. There's another one called the sine rule, which is sine A over A equals sine B over B. I won't bother deriving that today. Another time, something to look forward to. But that's it for today. I hope you enjoyed it, and I'll see you next time.